Assalamu alaikum. Dear students, in this lecture we will discuss the solution for the problem number 7.16, which is the point of support of a simple pendulum of mass m and length b is now by a horizontal driven by x is equal to a sine omega t. Find the pendulum equations of motion. In this case, our sample pendulum is driven by a horizontal force which is x is equal to a sine omega t. So what will be the equation of motion? So in this case, our x coordinate will be again modified. We will resolve this mass, this weight into two components, one along the horizontal and saying along the vertical. So our for mass m, x will be equal to a sine omega t, because when we resolve this b into two components, so definitely it will theta will be in front of this angle, sine theta will be in front of this theta, so it will be, could be sine theta and a sine omega t. And similarly below the origin will be cos theta y is equal to minus b cos theta. Then we will need x dot and y dot. You know that we can resolve this into two components like this. If I draw the diagram, like if we resolve this mass, this length b into two components, so this in front of theta will be sine theta, b sine theta, and this will be b cos of theta. So you know that here we have origin, so below the origin y will be minus b cos theta. In this vertical direction y is equal to minus b cos theta, and in this horizontal direction y x is equal to b sine theta plus a horizontal driven component which is a sine omega t. So x will be equal to a sine omega t plus b sine theta, and y is equal to minus b cos theta. When we take the dot derivative of x and y, so we will have x dot will be equal to a omega cos omega t plus b theta dot sine cos omega t. We can take the derivative of x. Similarly, we can take the derivative of y with respect to t. Y dot will be equal to minus theta dot sine theta. The kinetic energy of the system will be equal to m over 2 x dot ka square plus y dot ka square. So we can find the kinetic energy, which is equal to m over 2 x dot ka square plus y dot ka square, and we have x dot and y dot. We can just take it the value of x dot and y dot and will plug in this expression. So this will give us kinetic energy. Similarly, the potential energy of the system is u is equal to mgy, and then by substitution of x dot and y dot in this kinetic energy expression, it will give us m over 2 b square theta dot square plus this whole term, and substitution of y in this potential energy expression, it will give us u is equal to minus mgp cos of theta. Now at this point we have kinetic energy and potential energy, and we can find the Lagrangian, which is equal to t minus u. You know that if we have Lagrangian, we can just put into Lagrange equation, and it will give us equation of motion for both of the coordinates. So Lagrangian is equal to this. By substitution, the Lagrangian equation, Lagrangian into Lagrange equation, we will have two coordinates, one for theta and similarly d over dt partial L over partial theta dot minus partial L over partial theta, which is equal to 0. So when we plug this Lagrangian into this equation, it will give us equation for theta, which will be theta double dot minus a over b omega square sine omega t plus this. And then I think this was the only requirement of our question. So if I look back, just so that we have solved the question completely, or some part is remaining. Find the pendulum equation of motion. Okay, it means we have, solve the equation of solve this problem for the equation of motion, which is just this one, theta double dot is equal to a over b and this whole term. So I will stop at this point.